Okay, so let's quickly look at this. All right, so suppose we wanted to graph y equals negative 2/3 x plus 4. And that was on your, something like this was on your last test to begin with, so you should have gotten those points. But we're going to use a t-table. Now when I use the t-table, and I'm just going to plot 2 points rather than doing 3 this time for time purposes. But y is by itself. So remember, we stated that whenever one of the variables is by itself, that's the easy kind to graph. In this case, y is already by itself. So you can pick numbers for x. Now, what kind of numbers for x would make things a lot easier for you? Divisible by 3. But what number is always divisible by a number? 0. So I'm going to let x be 0. Now, when x is 0, what's negative 2/3 times 0? 0 plus 4 is 4. So I have one of the points. If x is 3, and I'm going to go ahead and do the 3 points. If x is 3, I get y equals negative 2/3 times 3 plus 4. What's this product right here? What is it? What's this product? What's negative 2/3 times 3? What is it? Negative 2. 3 goes into 3 one time, 3 goes into 3 one time, you're left with negative 2. Negative 2 plus 4 is 2. If x is negative 3, I get y equals negative 2/3 times a negative 3 plus 4. What is this product right here? A negative times a negative is a positive. What is this product right here? Positive 2. 2 plus 4 is 6. All right, so I'm going to plot those points. 0, 4. I'm actually going to leave 0, 4 alone for right now. 3, 2 is here. And then negative 3, 6 is here. All right, so I'm going to label those points. 3, 2, negative 3, 6. Angela, you have those. You have worksheets A and B with you. Go ahead and turn them in. All right. Now, when I graph this, or when I look at this, what kind of slope does this have? Negative slope, because it's falling. Okay. Now, let's go ahead and find a slope using a slope formula. I'm going to use those 2 points here. So the slope equals, I'm going to call this x1, this will be y1. So therefore, this has to be what? x2, y2. All right, I'm going to use the slope formula that starts with y2. So y2 minus y1 over x2 minus x1. What's y2? 2. Subtract y1. What's y1? 6 divided by, now since I started with y2, I have to start with x2. What's x2? 3 subtract negative 3. What's the numerator? What's 2 subtract 6? Negative 4. What's the denominator? What's 3 subtract the negative 3? No, it's not 0. That's 3 plus 3. 6. Reduced, what do you get? Negative 2/3. Okay, so the slope is negative 2/3. And we said it had to be negative. All right, now, look at the equation. Do you see negative 2/3 anywhere? Yes, right here. It's a coefficient of x, right? And what is the y-intercept if you look at the graph? Where does the graph cross the y-axis? At 4. Do you see 4 listed anywhere? Yes, it's right here. So whenever you get y by itself, whenever y is by itself, you can easily determine the slope in the y-intercept. So that's called, this right here is called slope-intercept form. Slope-intercept form. Yeah, F-O-R-M.
The way the problem is written.
Whenever you get y by itself, it's slope-intercept form. So slope-intercept form is y equals mx plus b. That's slope-intercept form, y equals mx plus b. So remember the symbol for slope is m. And so notice whenever you get y by itself, whatever you multiply an x by, the coefficient of x, that's your slope. And the constant is your y-intercept, and we denote it as b. B is denoted as the y-intercept in this equation. So this is your slope. Because this is a y right here. That's why. And this is your y-intercept. Okay? All right. Now, so you know now, whenever y is by itself, you can easily determine the slope and the y-intercept, right? Okay. So, if you have y equals, example, let's say we have y equals 3x minus 7. And find the slope and the y-intercept. What's the slope? 3. No? Okay, someone said 3x. It is not 3x. The slope is a coefficient of x. What's the slope? 3. You say 3x, it's wrong. Okay? Where does a graph cross the y-axis? -7. Don't say 7. It's -7. The constant's -7. Right? You didn't have to graph it. You didn't have to use the slope formula at all. When you get y by itself, what form is this in? Slope-intercept form. So whenever it's the slope-intercept form, you know the slope and you know the y-intercept. It doesn't say anything about the x-intercept. It only tells you about the what? The y-intercept. That's all it does. Okay, number 2. Let's suppose you had y equals -6/5 x minus, let's say plus 2. What's the slope? -6/5. And what's the y-intercept? 2. So the graph will cross the y-axis at 2. Okay, number 3. Again, you want to find, so I'm going to put right here, find the slope and y-intercept. Find slope and y-intercept. So for each of those, find the slope and y-intercept. Okay, here's the next one. Y plus 6x equal 5. Is y by itself? No. So we have to get y by itself. So what are you going to do to both sides? Subtract 6x. And so when it subtracts 6x, combine like terms, this is 0. And we tend to put the variable first. Always put the constant last. So how would you rewrite the left side? And those are not like terms, so don't say 5 minus 6 is a -1. They're not like terms. -6x plus 5. Now you can tell me what the slope is. -6. And now you can tell me where the graph's going to cross the y-axis. At 5. Okay? 4. 2x plus y equal 7. Subtract 2x from both sides. Because you get y by itself, right? You want to get it in what form? Slope-intercept form. So combine like terms. I get y equals -2x plus 7. So now you know the slope. What's the slope? -2. What's the y-intercept? 7. Okay. Number 5. Suppose we had -3x minus y equal 6. -3x minus y equals 6. All right, so again, you get y by itself, right? So you're going to add 3x to both sides. Okay, to combine like terms, that's 0. Now be careful, it's not y that you have, it's what? -y. So you have -y, and I'm going to go ahead and write as -1y, equal, and then that becomes what? 3x plus 6. So that's where I'm at. Okay? Then divide both sides by -1. Okay, so I'm going to do this. I'm going to go ahead and write it right here. So I'm going to say, I'm going to just go ahead and rewrite this equation over. I'm going to divide both sides by -1. What I do to one side, I do to the other, just like this. Reduce. -1 divided by -1 is 1. 1 times y is y. All right, now remember, we mentioned this before, that if I have 6 plus 2 divided by 2, you agree that 6 plus 2 is 8, right? And 8 divided by 2 is 4. You also agree that I can rewrite this as 6 divided by 2 plus 2 divided by 2. And what's 6 divided by 2? 3. 2 divided by 2, and you still get 4. So whenever you're dividing by one term, a monomial, one term, a number, you can break it down in two fractions. All right, so that's what you want to do with this. So in order to get into that form, y equals mx plus b, y equals mx plus b. In order to get in that form, you want to write it as two terms, two fractions.
So you put it
This and this.
as y equals -3x minus 6.
That's what we're about to do. So you can write this as two fractions. 3x divided by -1 plus 6 divided by what?
-1.
Now, what's the answer you're supposed to give me now?
-3x plus, or -6.
Minus 6, because a positive divided by negative is a negative. So that's what you need to give me. Don't give me this one here. I need you to write it in the form y equals mx plus b. Okay? Now, what's the slope?
-3.
And what's the y-intercept?
-6.
-6. Okay? All right, number 6. All right, number 6, suppose you had this. Suppose you had 5x minus z plus 2y. Plus 2y equal, let's say, -20.
Subtract 5x and so on.
All right, so again, you want to find the slope of the y-intercept. To find the slope of the y-intercept, you need to get in what form? Slope-intercept form. Slope-intercept form is where you get what letter by itself? Y. So I'm going to subtract 5x from both sides, just like this. Combine like terms, that's 0. What's left on the left?
2y.
Equal,
-5x minus 20.
yeah, -5x minus 20. Good. And then the next step is to do what now?
5 goes back by 2.
Okay, good. No issue. I'm going to do it like this. And you could skip that step if you want to. So you can go directly to the two fractions. So you're going to say y equals -5x divided by what? 2. And a -20 divided by 2, which is a what? -10. So there's your slope-intercept form. You all agree? Okay. But again, you could have gone from here to there without actually showing the division by 2. Now what's the slope?
-5.
Halves. What's the y-intercept? -10. All right. Number 7. Suppose we had 6x minus 2y equal, let's say it's 7.
Subtract 6x from both sides.
Subtract 6x from both sides. Combine like terms at 0. What's left? -2y equal
-6x
plus
plus 7.
7.
Divided by -2.
Divide both sides by -2, just like this. Now be careful though, because you're going to say -6x divided by a what? -2. Now you got to remember, so for some of you, you may want to write this out right here. You may want to say that's going to be y equals -6x divided by -2 plus a what? 7 divided by a -2. But you got to remember that a negative divided by negative is a positive, so this really becomes what? 3x. Yeah, just go ahead and don't say plus the -7 halves. We prefer to write it as just 3x minus 7 halves. So what's the slope?
3.
What's the y-intercept?
-7 halves.
-7 halves. Okay? And so that's that part D you had to turn in, or that part E, one of those. Part E, I think it was. That's all that was. You get y by itself. All right, so on that part, you had to turn in that part E. That's why I forced you to say was due today, so that way you can have practice getting y by itself. So that should not have been an issue if you did that worksheet, getting y by itself. But now you know that when you got y by itself on that worksheet part E, what form was that? Slope-intercept. And so once you get y by itself, you can determine the slope and the y-intercept. Okay? So that's all that was. All right, now, you also learned from that worksheet that if you have parallel lines, so parallel lines, and this is still section 10.4, all this was section 10.4. So if you have parallel lines, and remember, parallel lines from that worksheet that I asked you to work on are lines that do not what? Intersect. They don't intersect at all. So if you look at those two lines, and remember, sometimes we refer to a slope as a tilt, so they have the same tilt, right?
Mm-hmm.
And so really what that means is they have the same slope. So parallel lines have the same slope. And then on that second part of that worksheet, you were to graph two lines. I didn't mean to be. You had to graph two lines that were perpendicular to each other. So if you think about it, if they're perpendicular, one's positive, the other going to be what? Negative. And one of the things you saw, and we don't have the time to do that here, that's why I asked you to do in that worksheet, one of the things you saw was this, that if this slope here is 4 fifths, positive 4 fifths, it had to be positive because it's rising, then you learned that the other line, and remember perpendicular lines form what kind of angles? Right angles. So all these angles are right angles. That's what that means. Perpendicular, they intersect at right angles. That's what that means. Now if you had a protractor, which you don't, you could have easily determined they were right angles, but you were just watching it or looking at it by inspection. They look right angle, so it must be perpendicular. But you can use a protractor to actually see that. So if for those of you that did that worksheet, that was due tonight, now it's due Tuesday, but if you did that worksheet, if this slope was 4 fifths, what was the slope of this line? Nope. Not negative 4 fifths, negative 5 over 4. So remember, one of the phrases in that worksheet was the idea of negative reciprocals. Okay, negative reciprocals. So what's the reciprocal of 4 fifths? 5 fourths. But they have to be negatives of each other. So if this is positive, this has to be negative. So it will be a negative 5 fourths. Okay? So perpendicular lines have slopes that are negative reciprocals of each other.
Say it one more time, please.
Say again?
I was asking you to repeat that.
Perpendicular lines have slopes that are negative reciprocals of each other. And we saw that if you multiply them, if you were to multiply those two slopes, 4 fifths times a negative 5 fourths, what's that product? Negative 1. 5 into 5 is 1, 5 into 5 is 1, 4 into 4 is 1, 4 into 4 is 1. 1 times negative 1 is a negative 1. That was one of the things in that worksheet you looked at. Okay? All right, now let's look at this. Now listen carefully to this. Determine if the pair of equations are parallel, and I'm going to go ahead and use, well, I'll go ahead and write it out. But the symbol for parallel, sometimes I'll just use this symbol for parallel. Like little two parallel segments. Parallel, perpendicular, perpendicular, And recall from high school geometry, and for some, maybe a while, but recall from high school geometry, the symbol for perpendicular is an upside down T. Looks like that. You see the two angles where they meet looks like right angles? Or neither. So neither means that they're neither parallel nor perpendicular. That's what that neither means.
For some reason, parallel there, this popped in my head. Parallel here. Nothing like geometry flashcards.
Okay, so number one. So we're going to start with an easy one. Y equals negative 3x minus 10. Y equals 3x plus 6. Okay, so on that worksheet, on the test, you could be asked this. You could say, determine the slope of the y-intercept first. So if I want to determine if two lines are parallel, perpendicular, or neither, I got to find the what? The slope. That's all I need to know is what's the slope. I don't have to know anything about the y-intercept at all. I just need to know the slope. Because you know that two lines are parallel, they have the same what? Slope. Two lines are perpendicular if their slopes are negative reciprocals of each other. Okay? Not just reciprocals, but what? Negative reciprocals. So if I want to determine if those two lines are parallel, perpendicular, or neither, I've got to find the slope. So what's the slope? Negative 3. What's the slope here? Positive 3. Compare those two numbers. But are they the same? No. Are they negative reciprocals of each other?
No.
No, they're not. What is the reciprocal of 3?
-1/3.
Well, first of all, the reciprocal of 3. What's the reciprocal of 3? Reciprocal. 1/3. Do you see a 1/3 anywhere? No. So those two lines, they won't be parallel because the slopes are the same. They will be perpendicular because the slopes are not negative reciprocals of each other. So he's going to say what? Neither. Now, what that means is that the lines are going to intersect. They're going to intersect. One's positive, the other one's what? Negative. But are they going to form right angles? No. They're going to look something like that. That's all that means. Okay? They are going to intersect. Why you know they're going to intersect? Because the slopes are not the same. Right? Parallel lines are the only lines that do not what? Intersect. All other lines do what? Intersect. So they're not parallel, they're going to do what? Intersect. So how do you know that those two lines are going to intersect?
Because they're not parallel.
Because the slopes are the slopes are the same. One's -3, one's +3. The slopes are not the same.
Because they're not reciprocal. Negative.
That has to do with perpendicular. All I asked was this. How do you know that the lines intersect? Because the slopes are not the same. So these lines are going to intersect because the slopes are not the same. All right. Now again, the easy kind is when y is by itself. So what form are these two equations in? Slope-intercept form. So you can tell me the slope of each one. What's the slope of the first one? What's the slope of the second one? What do you notice about their slopes? They're the same. So the line's going to do what? Be parallel. So since the slopes are the same, the lines are parallel. Over here, since the slopes are not the same, you're going to say neither. Now, remember by neither, all you're saying is this. The lines are neither parallel nor what? Perpendicular. That's what that neither means. The lines are not parallel and they're not perpendicular. But they are going to do what? Intersect. They're just not going to intersect at right angles. All right, let's suppose we had,
I got a question.
yes,
You said if the slopes are the same, they're supposed to be parallel, right?
that's correct.
So the slope is 2/3 and 2/3, right?
That's correct.
So the slopes are not, but wait, are those slopes, are they parallel or perpendicular?
Well, what do you notice about the numbers?
I mean,
I'm asking you the question. What do you notice about the numbers?
they're the same.
So what's this? What are those lines parallel, perpendicular, or neither?
Parallel.
Okay. All right, now you got to get into a little bit more work. Number 3. You want to determine if the lines are parallel, perpendicular, or neither. The second equation, you can tell me the slope. What's the slope of the second equation? 3. So that one's easy because y is already by itself, right? But the first equation, y is not by itself, so you got to do some work. So let's go ahead, and that's that first part we did at the beginning of the class, where we got y by itself. So we got to do some work here. So I'm going to do the work here. So we got to get y by itself. So I'm going to go ahead and rewrite the equation so I can have some space here. All right, what are you going to do next? Subtract x from both sides. And so I get negative 3y is equal to negative x minus 6. Okay? Then divide by what? Negative 3. I'm going to go ahead and rewrite this over. All right, now we got to be a little bit careful with this. So I'm going to go ahead and write the two fractions. So I get negative x divided by what? Negative 3 minus 6 divided by what? Negative 3. Okay, now, what is that? If I cover that negative 3 right here that's in the denominator, what's that coefficient of x right here that's in the numerator? Negative 1 though, right? So if you need to, you may want to put a little negative 1 here. Now let's rewrite this. So y equals negative divided by negative is a what? Positive. So it's going to be what? 1/3 x. Very good. And negative divided by negative is a what? 6 divided by 3 is what? 2. So it'll be plus 2. There we go. All right? So don't forget, negative x divided by negative 3 is not 3x. It's what? 1/3 x. So what's the slope now? 1/3. All right. So that's where we're at. Compare the two slopes. Are they the same?
No.
Nope. So they're not the same, and you were to graph it, they would intersect. Now I'm going to ask you this. Would they intersect at right angles? Nope, because the slopes are not what? Negative reciprocals. They're reciprocals. What's the reciprocal of 3? 1/3. But they're not what? Negative reciprocals. In other words, one's not positive, the other one's not what? Negative. That's what that means. So you're going to say parallel, perpendicular, or neither? Neither. So the answer is neither.
So your first one is -3, which would be -3/1, and the second one is just 1/3, 1/3.
Now that's positive 3.
Well, correct. The second one,
Second one's positive 1/3.
correct. And the top one is negative. So there.
That's positive 3. I'm not sure what you mean by
The
negative.
top one's positive. What are you saying is positive?
Right here, the second equation has slope 3.
You're talking about the one we just did?
This one we just did, all the work is 1/3, Angela.
Right, I know that.
Okay, so that one right here, the second equation, is slope is 3. Where are you getting negative 3 from?
The first one, doesn't that say x minus 3y equal -6?
Yes, but you got to get y by itself.
Oh, I'm sorry, that's the one we saw.
That's all what we're
Never
doing,
mind,
girl.
I'm sorry.
All right, it's okay. I forgive you. You're forgiven. It's been a long,
It's been a very long day. Long week. Yes.
it's a long decade, right? All right. Let's It's a long 2 decades for me. Okay, next one. 6 plus 4x equal 3y. 3x plus 4y equal 8. Now, Angela brought up a good point, though, because some of you are going to think that because you're going to think that maybe the slope is -3, or you could probably say the slope is 1 because you say the slope is a coefficient of x, right? But it's not 1. You got to get what by itself? Y before you say what the slope is. All right, so remember, it's not always the coefficient of x. It's the coefficient of x only if what letter's by itself? Y. So over here, is my slope 4? No, because why? Y is not by itself. It's not in slope-intercept form. Same thing here. The slope is not 3 because it's not in slope-intercept form. So both of these equations, I got to do some work. So let's do the first one. Now, the first one's easy because the 3y is already on one side. Just divide by 3. That's all you got to do. So divide by 3, and then I'm going to go ahead and write in 2 fractions. So 3 divided by 3 is 1, so I get y equals 6 divided by 3 is 2 plus 4/3 x. All right. So what's the slope? 4/3. That's your slope. Okay. Over here, let's get this in slope-intercept form. So let me go ahead and just rewrite it. So you're going to subtract 3x, correct? And always put the x term first. So it'll be 4y equal what? Okay. Then divide by what? 4. And when I do that, I'm going to get, and remember, don't leave it like this. You leave it like this, you're going to be upset. You leave right in the form mx plus b. -3/4 x. A positive divided by positive is a positive, plus 2. A divided by 4 is 2. So what's the slope? -3/4. Okay? So some of this is some work you got to do. So that's why you've been practicing solving equations and using all those properties to get to that point. What do you know about the slopes? Are they the same?
No.
No. So the lines are not parallel. They're going to intersect. Are they going to intersect at right angles?
Yes.
Yes, because the slopes are negative reciprocals of each other. So since the slopes are negative reciprocals of each other,
I have a very probably dumb question. What do we do with the little extra on the end?
that's your y-intercept.
That's what I
Now, so since the slopes are negative reciprocals of each other, the lines are perpendicular. All right, the lines are perpendicular. All right. Now, as you worked on that worksheet, you notice that in a plane, if you have 2 parallel lines, they have the same slope, right?
Yes.
Remember, the definition of parallel lines is lines that do not intersect. So they have the same slope. What is about their intercepts, their y-intercepts?
They're not the same.
Different y-intercepts. Okay. Then when we talked about perpendicular lines in a plane, we saw that the slopes are negative reciprocals of each other. All right, so you got to remember what we mean by negative reciprocal. So the idea of reciprocals, one's negative, one's going to be positive. So the slopes are negative reciprocals of each other, and then also notice they have different what?
Y-intercept.
y-intercepts.
Well, wouldn't they have to be on top of each other to have the same?
Okay, so she's asking this: if the lines, if you have two equations, and they overlapped, we don't say those are parallel. Those coincide. Remember, parallel lines don't intersect. If they overlap, they are intersecting. It's actually the same equation, by the way. All right. So remember, the definition of parallel lines: two lines that do not intersect. So her question was this: since slopes are negative reciprocal to each other, so you have different and different y-intercepts. So if you have y equals 2x minus 4 and 2y equals 4x minus 8, okay? Those are two equations, and you're going to graph both equations. But when I graph both of them, when I graph those equations, and you get y by itself here, what do you notice? They're the same. So when you graph both of them, they do what? Overlap. Now the slopes are the same, so you might say, oh, the lines are parallel. They can't. We don't say those lines are parallel because parallel lines do not what? Intersect. Well, those are the same equation, so they're going to do what? Overlap. So when you graph one of them, when x is 0, y is negative 4, right here. When x is 2, y is 0. So when I graph this, 0, negative 4, and then 2, 0, that's the equation of this, that's the graph of this one, but it's also the graph of what? That one.
So in the world of math, are those considered two different lines?
No, they're the same line that we say to just coincide. These two lines coincide. We don't say they're parallel because parallel lines do not intersect. Coincide. So they overlap. You see something like this when you talk about systems of equations in college algebra. In systems of equations in college algebra, you could have two lines that overlap. And so that's where you start talking about solutions of systems. But they are related to graphing two lines in a plane. You're going to see that in college algebra. All right, so when you do worksheet 10.4c that you just picked up, you'll see that this is what we talked about. So notice in these, y is already by itself, right? So it's easy to determine the slope and the y-intercept. Over here, you got to get y is not by itself, so you got to get in what form? Slope-intercept form. So you put in slope-intercept form, you got to say y equal. Don't say 3x minus 1. You got to say what? Y equals 3x minus 1. Okay? And then you say the slope and the y-intercept. So that's that first part. That's part C. So this part you can do within a minute or so, this part here. Then part F. Part F is this. So this is where you determine whether each pair of lines is parallel, perpendicular, or neither. Now these are easy because what do you notice about those equations? They're already in slope-intercept form. Okay? Here they're not. So you do some work on a scratch paper and you put in, you just tell me what the slope is for both, and you compare the slopes, and that determines whether they're parallel, perpendicular, or neither. So in the answer part, you're going to write what words? Parallel, perpendicular, or neither. Okay? So that's that part. Part F, that was part F. Part G, you got to practice. You have to practice. And I mean, for every 7, you can drop 2, right? So you can slow down that way if you want to.
I love your worksheets, sir.
They're supposed to help you on the test.
And I
All right.
there's not a lot of them.
Say it again.
I'm not gonna say there's not a lot of them.
Oh, it is a lot of them. That's the only way I can get you to. If all you did was the My Math Lab, you wouldn't do well.
I wish we could do away with math lab. Math lab is stupid.
All right.
With technology.
So in part G,
The F or G?
that's part G.
This here?
That's part G.
Oh, I don't know what I thought you were talking about part F.
We were talking about part F. This is part G. Okay? In part G, you're given two lines. You're told that line A is parallel to line B. You're told the slope of line B is 5. Okay? Then you're asked, what is the slope of line A? All right, well, they're parallel, then the slope of line A has to be what? The same. So you tell me what it is. And then perpendicular. So it's the stuff we talked about. Now here in part 3, it says find. Let me go ahead and actually do one like that. Yes. So again, for every 7, you can drop 5. So you don't have to do all of them. But it's up to you whether you want to practice or not, right? So please don't ever say slow down with this.
I know you don't want me to say it. I just had to do it. I had to do it. That's it. I'm done.
It's giving you the eyes.
I know. I'm quiet because I don't want to.
Again, as I said, Erica, you don't have to do them.
I'm going to.
Okay.
I have to express that there's a little feeling.
All right.
I really do love you, Mr. D. I really had to say that.
All right. So here's find the slope. Find the slope of the line. Write this down. Find the slope of the line that is parallel to the line through these points. Through these points, and these points here. All right, so find the slope of the line that is parallel to the line that goes through these 2 points. That's what it's saying. Okay? So if you were to put that in a coordinate plane, and anyone has an extra coordinate plane? Erica, you said he had an extra one. Can you give it to me, please?
This?
Yeah.
Okay. Olivia.
I'll get it. Actually, I may need both of them. Bring both of them. Thank you. Okay, so basically what this is saying is this. If I plot those 2 points here, negative 4, 6, which is here, and then 2, negative 4, which is here. All right, so you see I applied those 2 points, right? And I'm drawing the line. So here's this line. So see this part here? The line going through these 2 points? That's this. The question is this. It says find the slope of the line that's parallel to this one. But not that one. You see what it's saying? So it doesn't matter. It doesn't matter. But how would you determine the slope of any of these other lines, guys?
Parallel lines have the same slope.
Good. What else? How can you use that with this problem?
The Y2 minus Y1 formula?
But I need for you to tell me why you're doing the slope formula. How are you using the slope formula?
See where it causes the extra.
All right, listen. Listen to me. If I want to find the slope of any of these other lines, then I'll find the slope of this one. Because I know the points. So if I want to find the slope of this line, and I'm given this line here, then I'll find the slope of this line. Using what formula? The slope formula. Y2 minus Y1 over X2 minus X1. So the slope here is going to be negative 4 subtract what? 6 divided by 2 subtract a negative 4. What's the numerator? Negative 10. I don't know where you get an 8 from.
She's drunk.
And 2 subtract a negative 4 gets 6. Reducing this, what do you get? Negative 5/3. So that represents the slope of this one, right? So what's the slope of the other lines parallel to it?
Same thing.
Same thing. So what's the answer?
Negative 5/3.
Negative 5/3. So if you want to find the slope of a line that's parallel to another line, and these points are given, find the slope of that line. And then the slopes are then going to be what? The same. All right, now let's change it around. Let's say we had this. Find the slope of the line perpendicular to the line that passes through or that contains the points. All right, so find the slope of the line perpendicular to the line that contains the points or passes through the points. And this time, let's say we have negative 2, negative 7, negative 6, 11. I'm making this up. Let me change the 11 so I can put it in a grid. Let's just say 4. Let's do 4. Change it to 4 so I can use the grid. So basically what it's saying, and again, you really don't want to use the grid paper because on a test, which is timed, you don't have time to do this. You want to think about it. How would you do it here? So if I were to graph it though, I have negative 2, negative 7, which is here, okay? And I have negative 6, 4, which is here, right? And if I graph this line, all I'm asking is this. What is the slope of a line that's perpendicular to this one? So in other words, and remember, perpendicular lines form what kind of angles? So no matter which perpendicular line I draw, and there's an infinite number of them. Y'all agree there's an infinite number of perpendicular lines? To find any of those, I got to find the slope of which one? The first one. And how do you find the slope of the first one? Using a slope formula. So if you're going to find the slope of the line perpendicular to this one, you got to find the slope of this one first. So we say x1, y1, x2, y2. So slope equals, and let's do y2 first. So 4 subtract what? Since I started with 4, I got to start with what? Subtract a negative 2. What's 4 subtract a negative 7? 11. Now, what's negative 6 subtract a negative 2? That's really negative 6 plus 2, which is a negative 4. So the slope is a negative 11 fourths. Okay? So therefore, the slope of the line perpendicular to it is what? The negative reciprocal.
But that one's already a negative.
No, negative reciprocal means you change the sign and take the reciprocal. So this becomes, so the slope of the line perpendicular to it is what? 4 of 11. Okay? That's all you do. So we go back to that worksheet, just to make sure you understand what you have to do. You go back to this worksheet. You now know how to do number 3, right? See where it says show work here? That's where you use the slope formula. And then it says the slope of the line that's parallel to the line through the points listed is whatever your slope is here. Whether it's parallel, you use the same slope. If it's perpendicular, use what? Negative reciprocal. All right? And then here, find the slope of the line that's perpendicular. So that's the one with perpendicular. Okay? Remember the problems on the next page. So I'm asking, line A contains these 2 points. What is the slope of line A? To find the slope of this line, you do what? Slope formula. What is the slope of the line parallel to it? These two should be what? The same. Perpendicular, these two should be negative reciprocals, and then negative reciprocals, perpendicular. So if this is 3/4, this right here should be what? Negative 4/3. Line D is neither parallel nor perpendicular. What could, so if this is 3/4, and this is, this is 3/4, and then it says line D is neither parallel nor perpendicular to line A, then what could the slope of line D be? Pick anything other than what? 3/4 are negative 4/3. So you could say 5, you could say 7, you could say negative 8/5, things like that, right? There's an infinite that you could pick. Okay. All right, so that was that worksheet. Okay? So it's not difficult. You can handle this. But that is on your next test.
Once semester over.
All right. In 2020.
I just want the test to be the 30th.
It's the Tuesday get back from the holidays.
We have so
So
many
they're
tests
probably the
that week, like
19th.
all of us must
I know, because of the holidays.
So it's not a holiday, if we got tests when we come back.
It's the holidays before, Angela.
Well, it's not time to spend my holidays.
Hey, did you just roll your eyes at me and Andrew?
I sure did. Yeah. All right. Now, okay.
No, wait, which
Now listen carefully to this.